Alright, welcome back guys. Today I've got to get this engine block off the ground. It's an older Gen 3 6.4 Hemi. They had a lifter failure, as a lot of them do, so I got that really cheap and had the block machined for these beautiful Wiseco pistons. So forged stroker piston. So if you'd like to build a 426 cubic inch out of the 392, that's the piston you want. But I'm going to get this up on the stand and show you guys what's going on. the balls again. The super deep skirt like the old Hemis. Cross bolted main caps. And at the back, that pattern actually fits the small block bell housing pattern, so pretty handy.
Surface rust on the deck, and also the balls also cleaned out with WD and Scotch Brite again. Good as new, I reckon. Tiny bit of surface rust, but it won't hurt anything. We'll get some on the other side. There we go, all cleaned up.
Alright, let's get these pistons measured up, and then we'll measure the bores and compare them, make sure we've got the right clearance as per the sheet. Now, the sheet says measurement is 1.3 inches from the bottom oil ring land to where you should measure with your micrometer. Let's get that set up. So 1.123 right there. Now that comes out just on that bottom coating line on both sides. So we'll measure in right there. So let's get this set up. Carefully measure this. Right, this is a metric micrometer, so I have to convert that to inches and compare the other one. So 104.8 millimeters. Let's take that and convert it. So I've got my micrometer in the vise here. That measurement for the piston is still locked away at the 104.08 millimeters. We've got an inch measurement to compare it to if we need to, so we can get our thousandths clearance. Got this ball gauge set up, and we're going to zero this off onto this micrometer. So when that little pin moves in and out, this one's fixed. Get that onto the middle of that. Try and get the center of the anvils, and we're looking for the measurement the maximum measurement on this dial. So when it's tightest inside these anvils is when it's correct. I'm going to move that 0 until I get just close, pretty hard with. A little bit more on that 0. Slipping off the anvils there. But I've got 0 nice there. Right in the centre of the anvils when it's at its smallest distance. Because if you tilt it sideways, you're going to be a bigger distance. So getting those centred is really important. And the tightest point is the shortest distance. So I've got 0 right there. So that's set to our piston size on these skirts. Now what we'll do, we'll take this across to the engine bore, and we can go through those and see what they are and then compare them, and we'll get our clearance. Alright, we're on our block again now. Piston spec sheets. Suggested clearance 4 thousandths of an inch. So this being set to the piston diameter, insert this into the bore. We're looking for our tightest point. Like I said before, if you're on an angle, you're going to have a bigger distance. If you're perfectly straight, you're going to have the tightest distance, smallest distance, and that's your measurement you're looking for. So if I rotate that up, see that swinging past, over, so the tightest point I've got right on 2.5. I'll go next door here, try this one. Two and a half again. Because that's our 0 point of the piston, I can compare how far away it is from that 0. You can check up and down the bore, top and bottom, middle, whatever you want to do. Consistently 2.5. And go mid bore just to be average. 2.5. Well, suggested on the sheet, but my machinist has done 2.5, so he must know why and better. So we've confirmed that all those bores are 2.5 thou, which must be fine, or they wouldn't have machined it that way. Right, I want to do a comparison using my snap gauge versus the die ball gauge. See if we can get a consistent measurement, just to double check. So snap gauge goes in, undo that, bangs into the bore, and then you can carefully wriggle it out and get a measurement with the micrometer again. Then we can get a straight up comparison. These aren't said to be that accurate, but I think they're pretty good being a fitter machinist. Just going to roll that out carefully, not too tight, and bang, let's lock that off. So I can get that inside this micrometer now. Get it centralised, give it a swing till it's just barely touching. Just get a feel for it. So I have just slipping through, just touching 104.13 millimeters. Let me get a conversion and come back. So after looking that up, I've got a original measurement of piston, 104.08 mil, which is 4.097 inches. Bore measured out 104.13 for 4.099 inches. So the difference between those are 2 thousandths. With the ball gauge it was 2.5, so yeah, we're good. The machinist knows what he's doing. He must have known something about the piston material I didn't, so happy days, they're all checked out nice. I thought I'd go over my measuring equipment quickly. This one wasn't super expensive, but pretty nice. It's 100 to 120 mil, I guess. Flip it over, what does it say? 100 to 125, there you go. In metric, I can convert it to imperial pretty easily. Snap gauge set, that can be pretty cheap. Don't splash out too much on those. One nice piece I bought was the Micrometers dial. Pretty sure that goes to 8 inches, so when I was doing push rod length measurements with this Giselle measuring tool, it's super good, super handy to be, within 1 thousandths on those increments on the dial, which is super nice. You can get your lengths exact. That's the most expensive piece there. Can't go past that brand for accuracy and repeatability. Just thought I'd tell you guys about that gear there. Hope you enjoyed the video, and subscribe, like, thank you.